Hello everyone, welcome back. My name is Mr. Cobalt, and in this video I'm going to show you how to find the unknown metal of a substance in a substance that's reacted to produce another substance. So let's get into this. Okay, so in this problem you have a sample of a substance that has an unknown metal, M2O3. So we don't know what the metal is, M. And we know that this sample weighs 11.205 grams. And we're telling us that we convert this substance into 15.380 grams of another substance that has the metal in it, MCl3. So we're converting this from an oxide, a metal oxide, to a metal chloride, and we don't know what M is. And so we're asked to find the identity of M. So again, one of the ways you're going to do this is to find the molar mass, right? So anytime they're asking you to find the identity of an element, most of the time, if identifying or finding the molar mass or of the substance is going to be what you're going to find, and then you could use that to put it into science, into the periodic table, look on the periodic table for that molar mass or something as close to that molar mass as possible, and that most likely is going to be your element. So remember, you have to know what molar mass is to do this. So molar mass is the amount of grams for 1 mole of that substance. So if you can find the grams or the mass of your substance in grams and also find the moles, then you can divide the mass by the moles and you'll get your grams per mole, which would be your molar mass of the substance. So that's one of the things we're going to do today, but we're actually going to find directly the molar mass. We're not going to find the moles and the grams separately from them. In this problem, we can't really do that. So I'm going to show you how you're going to do this by using your roadmap that you usually do. So here, because we're converting from one substance to a different substance, normally what would we do? Well, if we're given the mass of our substance, let's say we want to know if we're given a certain mass of this and we're given the reaction and we're given the balanced equation, then and we're asked, okay, well, how much of this substance would you form from this substance if you were given this amount? Well, you would follow the roadmap, the chemistry roadmap. And so let me write that down here. So again, the chemistry roadmap is you go from mass of A in grams to moles of A, and you would use the molar mass of A, MMA, molar mass of A, to convert from mass to moles. And then you would go from moles of A to moles of B using a mole ratio between A and B. And again, you would get that mole ratio from the balanced equation or from a formula. And then you would convert moles of B to mass of B in grams using the molar mass of B, right? So if we were given this mass of this substance and we're trying to find the mass of this substance in of a product, right? So we would start with the reactant, mass of the reactant, and let's say we don't know the mass of the product and they asked us for it, then we would start with the mass of our reactant, convert that to moles of reactant using the molar mass, and then we use the mole ratio in our balanced equation between A and B, between this substance and this substance, to convert moles of B, which would be MCl3, and then we would get mass of B from the molar mass of B. But we can't do that in this case um, because they gave us the mass, right? But we can set up the problem exactly in the same way we would solve it, but this time we don't know what the molar mass of M is, but we know how to calculate the molar mass of M2O3 by adding together the molar masses of the atoms of M plus the molar masses of O3, the three oxygens, and we could put that together in a formula, right? And so we could set this up in the same way. So let me show you how you do that. So they give me the mass of M2O3, so and then they tell me it forms this amount. So why don't I go through the steps through these steps to get to the mass of B, which is going to be this here. So I start with the mass of A, which is 11.205. So I start with 11. I'm going to start over here. 11.205 grams of M2O3 over 1. And then again, the first step here would be to convert the mass of A to moles of A using the molar mass of A. So I need to calculate the molar mass of this substance here. Well, we don't know what M is, but we can write out the formula for how you would calculate that out. So if I write that here, it would be we have two M's. We have two atoms of our metal. So that would be 2 times the molar mass of M. I'm just going to use M for molar mass of M. So it would be 2M plus whatever the molar mass of the 3 oxygens are. So if we add those together, we look on the periodic table, we know that oxygen is like 15.9994, or you could round to 16. So we add that together, and we have 40, it's going to be 47.997. Let me double check that. 47.997. Yes. So that's going to be plus 47.997 grams from the O2. So this here would be the formula for the molar mass of the M2O3 with the molar mass of M unknown, right? So we can put that in here. So this would be the grams of the M2O3. So again, grams of M2O3 is on top. So we're going to put this on the bottom. So that's going to be 2M. M again is we're using that as molar mass of M plus, or the grams of 1 mole of M, plus the 47.997 grams, and that's going to be M2O3. And then we have the 1 mole of M2O3 on the top. So grams of M2O3, grams of M2O3 cancel out. And so we got this together. Okay, so that's our first step. So now we're at moles of A. So we got moles of M2O3. So now we need the mole ratio between moles of A and moles of B. So moles of A is M2O3 and B is MCl3. So what's the mole ratio? We don't have a balanced equation. How are we supposed to do this? Well, we know at least atoms on both sides of your equation have to be equal, right? And we know we're going from M2O3 to MCl3, right? So that we at least know, right? We don't care about the oxygen being balanced. We don't care about the chloride ion being balanced. We just care about the metal, right? If we could get the mole ratio between these two, right, which is where the metal's going. The metal's going from here to here. There may be other products and reactants involved, right? The oxygen could be forming something. We have some sort of reactant that gives you the chloride ion. So where did that come from? We don't know. But we do know that all of the metal from this substance, from this reactant, ends up in this product. That's the assumption here. So as long as we can balance these two and make sure that we have the metals on the same side equal, then that will give us the mole ratio. So we know that there's 2 metals in this formula, but only 1 here. So we need 2 of these to balance the metals. So we're going to need a coefficient of 2, right? So now we know the ratio is 1 to 2. Now, are the coefficients for the balanced equation going to be exactly 1 and 2? No. If we had the full balanced equation, this could be a 2, this could be a 4, or this could be a 3, this could be a 6. We don't know, but the ratio is always going to be 1 to 2. So that's what's important. So we know that the ratio here is 1 to 2, so that's our mole ratio. So we're going to use that to balance. And so we know that we have moles of M2O3. So we're going to put 1 mole of M2O3 on the bottom and 2 moles of MCl3 on top. So the moles of M2O3 cancel out. Now we have moles of MCl3. And so our final step to get the mass, our goal is to get to this mass, right? So we need the molar mass of MCl3. So again, we don't know what M is, but we can write a formula that's going to represent the molar mass of MCl3. So for MCl3, we have 1 M, so the molar mass of 1 atom of M plus we have 3 chloride ions or chlorine atoms, right? So we can look up chlorine and calculate the 3 atoms. So multiply that by 3. When we do that, let me get the answer from my calculation. So that's going to be 106.35. So that's going to be 106.35 grams from the chlorine atom. So we have our M here. We're only looking at the formula. We don't care about the coefficient. So we have 1 M in our formula and 3 chloride ions. So the 3 together gives us that. So this is our molar mass formula for MCl3. So we're going to use that. So this time, since we have moles on the top here, we're going to have 1 mole of MCl3 on the bottom, and that 1 mole is equal to this formula here. So that's the number of grams. M plus 106.35 grams, okay, of MCl3. Moles of MCl3 cancel out. Okay, great. Now I have grams of MCl3 on the top. So normally, if I was looking for the grams, if I didn't know what the grams were, I would have to do this calculation and figure out what grams were if I knew what the molar mass of the metal was. If I knew this and I knew this, I would just do the calculation, multiply by everything on the top, divide by everything on the bottom, and I would calculate my answer and I would get this. But they gave us the answer. So this is equal to, I'm going to put the equals here. This is equal to what? I would calculate it normally and get the answer, but they gave us the answer. So we'll write that here. So that's equal to 15.380 grams of MCl3. So we have an equation here. We have one side, this whole thing here is equal to this here. So we have an equation and we have an unknown. We have one equation, one unknown. So now that we have our equation, all we need to do is solve this for m. And so we need to do our calculations. So what we'll do is we'll calculate the top. We'll clean this up a little bit and we'll start to solve this equation. So the first thing we'll want to do is multiply the top, get that together, and multiply the bottom, get that together, and go from there. So what we're going to do is when we multiply the top together, we get 22.41 grams. So we're going to get 22.41 grams multiplied by this part here. So M, the molar mass of M, plus 106.35 grams. Okay. And then for the bottom, it's going to be this. So we have 2M. So this is the molar mass of M2O3. So we're going to have 2 times the molar mass of M plus 47 point, there's a point there and a point there, 47.997 multiplied by 111. So it's just that, and all of this is equal to 15.380 grams of MCl3, right? Okay, so a little bit simplified. So now what we want to do is multiply both sides by this part. Let's get this over here. And so when we multiply this, right? So if we multiply this by both sides by this here, we get 2m plus 47.997, right? Multiply this by 2m plus 47.997. And what we end up with is, so this cancels out over here, and we get 22.41 grams times M plus 106.35 grams is equal to 15 point. Now, if we multiply this out, we can let's go ahead and multiply this out. So 15.380 can be multiplied by the 2m and the 47. So 15.380 times 2m. So that's going to be, let's check this out, 30.76 grams. So let's go ahead and multiply that. 30 point, where'd it go? 76 grams. 76 grams M. And then we multiply this by the 47, so that's going to be plus. And when we multiply that, that's going to be 738 point 19386. 19386. Okay, so that is this multiplied out. We have this. We can multiply this out as well. So that's going to be 22.41 grams, or 4 M plus 22.418 times 106. And that's going to give us 2,383. 2,383.3035. And then again, that's equal to this 30.76 grams M plus, oops, 738.19386. All right, so then now all we need to do is get the similar parts on the same side. So the m's are going to come together. So I can subtract 22.41 m from both sides. Subtract 22.41 m from both sides, and I can subtract 738.1936 from both sides. 738.1936. So when you do that, you end up with, hold on a second, 1645.109. So you get 16, what did I say, 1645? So 1645.109, 1645.109. And that's going to be equal to 8.35 m. 8.35 m. Right? And so now all I need to do, since m is our molar mass of the unknown metal, all we need to do is divide this by this, divide both sides by 8.35 to get m by itself. So 8.35, 8.35. And so then we get m is equal to, or the molar mass of m, that's the molar mass of m that we're solving for. The molar mass of m is equal to 197.02. So 197.02. And so now we have the molar mass of m. So at this point, we can look on our periodic table and find the element that is closest to that number. And when you do, you find out that the element is gold, AU. So that is our answer. So I hope this was helpful. If you enjoyed this video, if you like this video, please hit the like button and hit the notification bell on my channel. Please subscribe to my channel. Put a comment in the comment section. Let me know what you think. Thanks for joining me and have a great day.